Welcome and good morning, and thank you for joining us for today's Glemba Online Speaker Series. My name is Rhonda Bush, and I'm the director of the Global Leadership MBA program at the University of Texas at Dallas. We are happy and excited that you are taking time out of your day today to join us for today's session, A Holistic View of the Blockchain Ecosystem. Please note that you have been muted upon entry into the web session, and after our presentation, we will have a moderated Q&A. So throughout the presentation, please post your questions in the chat window so that we can jump right into the Q&A after the presentation has completed. So today I'd like to welcome our guest speakers. Dr. Cuneyt Akcora is currently an assistant professor of computer science and statistics at the University of Manitoba, Canada, as well as a University of Texas at Dallas Department of Statistics and Computer Science fellow, who will be joined by current UTD computer science undergraduate, Mr. Sudhanva Purushotham. They will discuss how blockchain technology garners an ever-increasing interest of researchers in various domains, and in addition, will address issues affecting blockchain application proliferation, the complexity involved, and the volume of data stored by blockchains. Starting with the core components of blockchain, they will detail the building blocks of blockchains and describe blockchain use cases and application domains such as the Internet of Things, supply chains, trade, and finance. So now, Dr. Cuneyt Akcora.
I want to thank Elizabeth McLean and Rhonda Bush for giving us this opportunity to talk to you about blockchain. Me and Sudhanva, we have been working on this space for the last 2-3 years, and we'll be sharing our research and insights. So I will be giving a holistic view of the blockchain ecosystem, and in the outline of this talk, I will briefly mention the history of blockchain. I will talk about what type of data is stored on blockchain, what are blockchain platforms, what are smart contracts, and I will talk about decentralized autonomous organizations which are used with tokens and stable coins in creating decentralized finance, which is the hot thing in blockchains right now. Then my colleague Sudhanva will take over, and he will go over ICOs and IEOs, and he will talk about e-crime and cryptocurrencies and industrial leaders in blockchains and how they are storing their data on blockchains. And he will conclude with crypto and institutional finance. Bitcoin started in 2008, just after the financial crisis. An unknown author called Satoshi Nakamoto posted a white paper to an online forum, and the title of the paper was a peer-to-peer electronic cash system. And after 3 months, he came back again and he shared a software, what we call a wallet, that downloads the Bitcoin to your computer, and then open source that software, and this software is now maintained worldwide by developers. In the beginning, there was only Bitcoin, let's say from 2009 to 2012. If you look at the books and articles, they all mention Bitcoin, digital currency, digital gold. The titles have these audible. So after 2012, blockchain has seen some very interesting developments in smart contracts, lightning networks, added privacy, and privacy coins. So these days, we can say that blockchain, this ecosystem, is much bigger than Bitcoin. In this figure here, I am showing how the blockchains depend on each other. For example, Litecoin was created out of Bitcoin by changing just a few software parameters in the code. We can talk about 3-4 main groups of blockchains these days. There is Bitcoin as cryptocurrency and Litecoin, for example, and Monero and Dash that comes from it. And then we can talk about blockchain platforms such as Ethereum and Neo. Then we can talk about other solutions, and some of them even predate blockchain. For example, Ripple is a payment system between banks, and they started before Bitcoin started, but now they are also considered a blockchain company. This figure comes from the 2018, when the price of Bitcoin reached almost $20,000, and the volumes are still there, but I hope that in May, around May, we'll have the next Bitcoin halving, which I will mention now, and the volume will reach these old values, these big values. But what is a blockchain network? For those of us who started using internet in 2000s, blockchain uses a very familiar technology. So every user has the full copy of the data. Each user can connect to the blockchain network by just downloading and installing a software. In this network, new users appear and existing ones disappear all the time. So there, you can just join the network or leave the network. Crucially, every user runs the same software to verify blocks. You have to use the same protocol that the Bitcoin people are using. You cannot just create your own protocol. This is the main thing. Each user is connected to a few other users only, and you don't know who these users are. So your software is automatically finding them on the network and connecting to them. And importantly, there is no trusted user, no central authority that tells you the data that you have stored as this version, which is the authoritative version. There is no trust in the network. And in this network, the goal is to have a single truth about data that can be verified by everyone. If we consider all these aspects except for the last one, peer-to-peer networks, for example, torrents and Napster that we used to use to download data from the internet, they all use the same technology. With the only difference that in these peer-to-peer systems, you didn't have to have a single truth about data. You could download a movie and the title of the movie would be irrelevant to the movie content. A blockchain is a distributed ledger, and the ledger means a book laying or remaining regularly in one place. And a blockchain contains thousands of blocks. Bitcoin these days contains around 600,000. Each block contains around 3,000 transactions. And the blockchain is just a chain of data blocks. However, the creator of the system, Satoshi Nakamoto, did not use the term blockchain in the paper. He mentions a time chain of blocks, but then this name caught on. Consider the network given in this figure below. Consider that a new user joins the network and wants to learn all these blocks starting from the first block. In this case, two users can give the new user conflicting versions of data. Which data should the new coming user trust? This is the main problem that Bitcoin solves through the blockchain technology. And in this case, Bitcoin data contains financial transactions, but blockchain can be used for any type of data. So, Bitcoin uses something called proof of work in its block mining algorithm. And block mining is just gathering the transactions waiting in the system, cleaning them, looking if they are valid, and building a block out. For this purpose, it uses proof of work, which is a very simple algorithm. In fact, the whole Bitcoin blockchain idea is so simple that I give blockchain as an assignment to my second-year undergraduate students. And the idea, the proof of work idea, comes from email spam detection. If you remember, in 2000s, email providers didn't give us gigabytes of inbox quotas. So we had like 5 megabytes or 10 megabytes, and the incoming emails would fill that quota, and after one point, you had to delete your old emails to receive new emails. In that setting, spam email was a huge problem because of these spam emails, you couldn't receive your emails. So developers, researchers developed this idea that whenever you send an email, you should append some information that shows you have done some work. This is called the proof of work. Consider this email on the left. I am sending an email to Alice, and it has some mail content. And at the end of it, as the last sentence, I have to create information that says this email has 35 words. This is the proof of work. Whenever I have to send an email, I have to append that information. And when I send this email to, for example, Gmail, Gmail looks at the email and decides whether send it to the users or just discard it because it's spam email. So the email provider runs this algorithm. If the proof of work is not attached to the end of the email, it just says, I don't care if this email is authentic or not. The proof of work is not attached. I will just delete it as it is. If the sentence is there, the sentence can be the same for every email. So you could create millions of spam emails and you could append this email has 35 words to each one of them. Next, the email provider counts the words in the email, for example, and checks if that number matches. If the number does not match, the email provider again discards the email because it's spam. Else, if the email passes through all these filters, then you see it can still be a spam email. So the spammer can really put his effort into creating millions of emails and can do proof of work for each one. However, he will be slowed down because in this case, for example, the proof of work is just computing the words. If you use more complex proof of works, then you cannot really compute billions of them. In this example, it's just counting the words, right? Proof of work can be parameterized, and this is a novelty in Bitcoin. So Bitcoin uses a difficulty level. For example, in this case, we could say your difficulty level is 50 and find a value that sums up 35 to 50. And then imagine that you cannot immediately subtract 50 from 35 from 50. You will have to try the values. You will try 35 plus 1, 35 plus 2, 35 plus 3, and then you will add all these numbers to reach 50. In that case, a bigger difficulty level means more operations in proof of work, right? Bitcoin these days, all blockchains, let's say, uses hash puzzles for this proof of work computation. But it is the same idea that I'm mentioning here. The hash puzzles have almost always increasing difficulties, and these days in Bitcoin, you need to try 10 to the power of 21 numbers to find a working nonce. And the nonce in this case is this integer that we are using here. So, proof of work for this trying and not finding, this trial and error, is a very costly algorithm to mine a block. It's not very ideal. Bitcoin assumes 10 minutes between every 2 blocks. So in these 10 minutes in the worldwide, thousands of miners are trying to find the nonce. They are not finding it. Others are finding. So many people just lose and waste electricity. Some researchers call this Bitcoin system a peer-to-peer heat engine because what it does is it just connects computers that are trying proof of work puzzles and just overheating. Another researcher says Bitcoin mining is an expensive way to bet that the price of Bitcoin will rise because you are spending electricity to mine Bitcoins and you are hoping that in the future Bitcoin price will be higher, so you will earn money from your spending. The worst and I think the most realistic saying comes from Eric Jennings. He says the cost for having no central authority in the system that you can trust about the data is the cost of that wasted energy. We have to spend that energy because we cannot trust anyone about the truth of data. So from the very beginning, let's say from 2012, people saw that Bitcoin had this engine underneath that is called blockchain, and they liked the engine more than the Bitcoin. So, however, one problem with the whole blockchain thing is that proof of work is very costly. So researchers have been working on finding alternatives to proof of work, and these are called proof of X schemes. The main idea is that you have to show that you have done enough work or spent enough wealth before creating the block. Whoever has the most work, has spent the most wealth, is allowed to create the next block. And why everyone wants to create the next block? Because creating the next block will give you Bitcoin rewards. In these proof of X schemes, we have proof of stake, where we have few participants that we trust. But in these cases, this is like the mobility on blockchain, rich gets richer. Then there is proof of burn, proof of ownership, proof of publication, and many others. These days, some successful blockchains are using delegated proof of stake, which means ordinary users are voting on other ordinary users to make them the miners of the next block. But these schemes have turned into vote buying schemes, so there is corruption on blockchain as well. Why do we need proof of work? one main difference between blockchains can be made that some blockchains may not need these proof of work schemes. Bitcoin, for example, is a permissionless blockchain. It's a public blockchain because any user can install the software, download the data, and can join the system, which may not be ideal. For corporate settings, this transparency means that rivals can learn company finances and buy-sell relationships, which is not ideal. So the permission blockchains were created for industrial settings. They consume less power. They are more secure because you know the participants. They are privacy aware because outsiders cannot see the data in the blockchain. But for all purposes, these are gated communities where the evolution is very small. Let's go back to cryptocurrencies. We said that Bitcoin was the first blockchain and it was just a financial application of the blockchain technology. Why should we stop at cryptocurrencies? If you look at these aspects, in the third aspect, we say that every user runs the same software to verify data points. In Bitcoin, this data is financial transactions, but it doesn't have to be. Data, in fact, can be anything. It can be notary documents, it can be pictures, identity documents, shipping logs, Internet of Things data. All of these can be put onto blockchain. So theoretically, you could put a movie on a blockchain. However, it will be very costly. Blockchains are useful if you want to make sure that once the data is written, it cannot be tampered with. So every update to the data will be visible. Nobody can rewrite the history of the data. So a question is, why would you like to put a movie on a blockchain? If you want to have a single version of that movie, you can put it to the blockchain. However, it will be very costly because imagine in this network, whatever data you put to the network is downloaded by all the participants of the network. These days, when you install the Bitcoin wallet software, it downloads around 150 gigabytes of data, financial data, to your computer. It is kind of like dead weight just staying in your hard disk. You cannot do anything with it. So this is the on-chain storage where you store all of the data on the blockchain, which is costly, which is not practical. There are off-chain storage alternatives. In these cases, for example, you store some proof of your data. That is what we call a hash. And hashes of data change whenever the data is changed. So if you store the hash of the data, in the future you can come, take the hash of the data again and compare to the hash that you stored in the blockchain. And if they match, that means data has not been changed, which is ideal. Then you could also store the IP address of your data in the blockchain, and you could say, here is our data. You can learn this address from the blockchain, and then you can directly go and check the data yourself. Furthermore, around 2013-14, people started to consider storing data and software code on a blockchain. Here in this picture, I am showing Vitalik Buterin. He created Ethereum to store data. And Ethereum has a currency similar to Bitcoin, which is called Ether. And the code that's called a smart contract is written in a coding language and then compiled to bytecode and executed on the virtual machine. And the smart contract code can be anything a user wants. So you could put any kind of software code into your blockchain. A user creates a transaction to upload the code, and once the code is uploaded, every network node downloads that code. And interestingly, once the code exists on the network, another user could create a transaction to call some of the functions in that smart contract. And once a smart contract's functions are called, they are executed at every computer that is connected to the Ethereum blockchain. For this reason, Ethereum is also called the world computer. Of course, putting software code to blockchain is expensive. Even putting financial transactions to Bitcoin was expensive. So contract creation takes more space, it's more expensive. However, once you put it there, afterwards, all the calls to the contract are billed to the people who are calling the contract. You don't have to pay in the future. Initially, these smart contracts were taught to encode some business logic. So this is why they are called smart contracts. They were people were thinking that companies will use them to write agreements, for example. Then out of these smart contracts, evolution happened, and people started to create crypto assets. These are called tokens, and started to trade them on the internet. If you go to blockchain explorer websites such as Etherscan, you could see all these tokens. ERC20, for example, creates fungible tokens. That means one of these tokens amount is equal to another amount. So there are no IDs. This is a bit confusing right now, but in the next standard, you will understand what I mean. Now, this next one is very interesting. ERC 721 token standard is used to tokenize assets. Each asset has a different ID, and one of the fanciest applications of this concept is the Cryptocurrencies on the Ethereum blockchain. These are basically Pokemons on blockchain. You can buy individual Pokemons because each one has an ID. You can marry them, they can have offspring, and then in a sense, this is the Pokemon ecosystem on blockchain. Now, consider that if you can give unique IDs to each asset on blockchain, you could basically tokenize your assets in real life, for example, your house, your car, and you could sell your asset on the blockchain. And ERC 721 is used for this purpose, tokenize crypto assets. Then I will talk about decentralized organizations and oracles. The decentralized autonomous organization is an organization that lives as an organism on the blockchain. It is started by smart contracts. A person develops some smart contracts, puts them online, and these smart contracts have some logic to them that can spawn new smart contracts, need existing ones, and then basically create an organism themselves. Decentralized autonomous organizations are used to run companies and organizations on blockchains, and the organization may expand by adding more smart contracts. More importantly, you can invest into these organizations and you can join their decisions by voting. So investors can interact with these smart contracts. These are ideal companies without any corruption because smart contracts show all the inner workings of the companies. You know what will happen if you put money, what will happen if some group of people vote in a certain way. But in these organizations, they need some data from outside world. For example, they need to know what is the temperature in New York City today if you are implementing an insurance organization. You need to know oil prices. You need to know token prices. Any kind of real-world information must be fed to these smart contracts, and oracles are used to send real-world information. Oracles basically create transactions that says New York City has 30 degrees today and sends it to the blockchain, and a contract reads the temperature information. If the temperature is, let's say, very extreme, then the smart contract can initiate an insurance payout to investors. So all of these things can be done. Next, I will talk about stablecoins and decentralized finance that uses both tokens and decentralized autonomous organizations. So a stablecoin is basically a smart contract-based asset whose price is protected against volatility. So the company creates a stablecoin and it says, I am creating 100 for example, tethers, and each tether is $1, and I am collateralizing $100 and I am putting them into the Bank of America. Stable coins are becoming very, very popular these days. In fact, their volume reached 60% of all Bitcoin and Ethereum transactions this year. But why would anyone use a stable coin? First, stable coins helps you avoid fiat currency conversions in transactions. So if you want to sell Bitcoin, you can sell Bitcoin and buy stable coin instead of US dollar. And you will pay less transaction fees. Second, you could use stable coins to cash out of the system, but still stay in the blockchain. So you don't want to cash out to US dollar, you want to cash out to stable coins, and the stable coins will always have the same price, so it is guaranteed almost that you will never lose price because the stable coin price will never decrease. Third, stable coins actually shield you from know your customer rules and other stuff in banks, so you don't have to open accounts in banks to cash out of blockchain. You can just park your money in stable coin. And As I said, most of them are pegged to US dollar. And here I'm showing you the price of 3 most popular stable coins in terms of US dollar. On the x-axis, we have the dates, and on the y-axis, we have the price of each stable coin in US dollar. They are supposed to be at $1. But as these stable coins are traded in real world, their price is never $1. It oscillates between 1.025 and 0.97. But as you can see, until this recent COVID scare, actually, they were very stable. So they were working. These stabilization mechanisms are achieved with algorithmic components and some other things. I will not go into detail about this. So the stable coins and this new wave brought decentralized finance. Investors can buy into stablecoin, and most stablecoins now come with a secondary token that governs the stablecoin. So there are 2 tokens. One of them is a stablecoin. The other one is the governance token. Investors buy the governance token to govern the stablecoin. So by governing, what I mean is you can decide to increase the supply. You can vote to decrease the supply. So you can vote on how the stablecoin price changes. You are kind of trying to make decisions. And if your decisions are good, if the stablecoin is used by many people, they will kind of pay an interest on them. And the holders of the governance token will earn money from it. Furthermore, these stablecoins can be collateralized. You can borrow stablecoins, you can lend them, and you can pay interest rates on them. So these things are used in decentralized finance these days. Here, for those of you who want to know more, I am showing 2 very famous stablecoins. One of them is MakerDAO. This is my favorite. That uses a double coin approach. And the second one is the Tether, which is a kind of notorious stablecoin because people suspected that Tether was used to push the price of Bitcoin to almost $20,000. So one problem with cryptocurrencies is that, for example, on Bitcoin, everything is public. All the transactions are visible. If you are a hacker, if you want to protect your identity, let's say, you cannot really protect. Governments can find you, many people can find you. Next generation blockchains are developed to hide who you are trading with, how much money you are sending, when you are sending, in a sense, just hiding all the information by using cryptography. It is possible. And these are Zcash and Monero blockchains, and they are still not fully legal because governments cannot see who is selling to whom on these blockchains. So there is some stress about it. Next, I will talk about darkness. This is the interesting case where the blockchains are really used. So we have these darknet markers that are not reachable by your browsers. You need to use specific software such as Tor and I2P to reach them. And on these markets, people are selling all kinds of stuff from heroin to passports to guns, everything, and they even ship intercontinental. Government sees them periodically. Every 6 months, you will hear in the news that the biggest darknet to the date was seized. It's a cat and mouse game, and it is still continuing. And in these systems, buyer basically lists its goods, and the seller sends the money to the darknet exchange addresses, and the darknet exchange address asks the buyer, asks the seller to mail the good. The mail is physically, the good is physically mailed to the buyer. And after some time in this escrow system, when the buyer says that the good arrived, finally the vendor is paid. These things are very popular, and at this point, I will leave the stage to Sudhanva. My colleague will talk about ICOs and others.
Hi there, everyone. So I'll start off just by briefly reintroducing myself. My name is Sudhanva Purushotham. I've been a research associate with Dr. Akcora and his team. So the first part of my presentation will be concerning cryptocurrency and institutional finance And the second part of it will focus more on blockchain as a technology and exploring some of the interesting use cases there. These are two distinct segments that have a sort of self-reinforcing relationship that I'll touch on later in this presentation. But for now, let's jump right into ICOs. So initial coin offerings are a decentralized fundraising technique for companies or projects. They work on top of protocols, which in most cases is Ethereum, and project tokens are sold on these platforms and they're used to represent shares or stakes in a particular project or organization. ICOs were significant and really rose to popularity because they removed barriers of entry to capital access. So typically, if you are a group or company of some type and you're trying to raise capital, you're going to have to do it from VCs or angel investors or some kind of institutional source. And raising money through these sources is very difficult as it requires the business and the project itself to be significantly developed. And there's also there's also a lot of regulatory oversight and legal liability involved. So ICOs essentially became a way for groups to bypass all of these issues, allowing many projects to raise institutional levels of capital without any public liability. So ICOs became very popular in 2017 with many projects raising hundreds of millions of dollars. But ultimately, ICOs had a very high failure rate because of a lack of regulatory infrastructure, lack of legal liability, and lack of third-party auditing on any of these projects. So to address some of these concerns regarding investor safety and investor protection, ICOs have kind of evolved into what are now known as IEOs, or initial exchange offerings. So the idea here remains the same, but instead of selling the tokens to the general public, tokens are listed exclusively on certain exchanges. And the idea here is that this would help investor protection because the exchange has a vested interest to sort of do due diligence on a project before listing its token. And that's just because in the case, if there were to be a fraud or something of any type, it would significantly affect the volume and the revenue of the exchange itself. So along with fraudulent ICOs, there are also a few other problems with cryptocurrency that many businesses and developers are trying to address. Pump and dump schemes are common in cryptocurrency trading. So the concept of this is that a small group of capital-rich investors will make a coordinated effort to quickly buy large amounts of a token at once. And this will cause a dramatic increase in price. And when other market participants see this, new capital enters the token because everyone has what's referred to as FOMO, or fear of missing out. So what will happen is the token will rise and rise and rise in price. And there's a second coordinated effort on the group of the original investors to quickly cash out all at once. And they'll take a handsome profit, and usually the price of the token is dumped. So ransomware is the act of stealing data of some kind and threatening either an individual or organization with that data in exchange for cryptocurrency. And money laundering is the process of funneling cryptocurrency through hundreds and potentially even thousands of different addresses to hide the origin of where those funds came from. Institutional finance is developing a growing interest in cryptocurrencies. The three main profit-deriving activities that financial institutions engage in are trading, asset management, and securitization. And cryptocurrencies provide a compelling means of profit generation in all three of these avenues. What's really causing the friction in quick adoption are issues surrounding compliance and data analysis. So on the compliance side, institutions need to be able to meet various kinds of anti-money laundering requirements. They need to be able to track the origin of funds, monitor the risk of their clients, and meet various other regulatory requirements that are particularly hard to meet because of the pseudo-anonymous nature of cryptocurrencies. And then on the data analysis side, because cryptocurrencies are a brand new kind of financial instrument, they have new ways of analyzing and understanding value. So there's going to need to be new kinds of data products, new algorithms, and new technology infrastructures to extract profit in these aforementioned activities of trading, asset management, and securitization as they relate to cryptocurrencies. So to address some of these needs and compliance that I've just outlined, Chainalysis provides a product for risk rating and for graphically exploring cryptocurrency transactions. ScoreChain provides a product for the real-time monitoring of clients, origin of funds analysis, anti-money laundering, and fraud detection. A screenshot of their product is actually right on the right-hand side here. And CipherTrace provides a wallet search engine combined with a database on hidden and risky websites, handles, and IP addresses. To address needs in data analysis, Santiment provides standard tick data on 1,200 different cryptocurrencies. Tick data is just your standard fields like open, high, low, close, and volume. They also provide social data, which is used to analyze market psychology and sentiment through keyword and language analysis on social networks. They have developer activity data, which is essentially just monitoring a project's GitHub to ensure that the developers and the project are staying productive and on schedule. And lastly, on-chain data is just different sort of network metrics that would be important to know, like network growth and stuff like that. So Santiment believes that by combining these four vectors of data, that this will provide a advantage in terms of price prediction. Kaiko provides a similar product that's more geared towards institutional finance. They have tick data on 3,000 assets, but they also provide level 2 order book data, which contains information like highest bid price, lowest bid price, highest and lowest asking prices, as well as all the asking prices. So that can provide a lot of transparency into the market for a firm that's dealing with cryptocurrencies. So the future of crypto and institutional finance will revolve rapidly around a rapidly developing regulatory infrastructure. There's going to be a lot of products that are focused on helping financial institutions build cryptocurrency-based businesses by ensuring that they are regulatorily compliant in a rapidly developing market with an ever-changing set of regulations. So more specifically, these are going to be products for anti-money laundering, pump and dump detection, origin of funds tracking, and so forth. And the way data products are going to develop in the near future is just by increasing in granularity. So these four categories of data are just going to become more in-depth and more insightful over time. So in the beginning of this presentation, I said that cryptocurrency as it pertains to institutional finance and blockchain as it pertains to general technology use cases are two distinct segments. So their relationship is essentially as follows. So as interest in cryptocurrency grows for trading, asset management, and securitization, more institutional capital is put into these blockchain projects. And more capital and more interest generated for projects means that blockchain technologies continue to develop. And as the underlying technologies develop, the intrinsic value of their tokens grows, and this incentivizes more cycles of investment and more cycles of growth. Now that we've discussed cryptocurrency as it relates to institutional finance and its relevance to the growth of blockchain technology, the remainder of this presentation will focus on compelling use cases of blockchain in various different industries. The first question that's relevant to ask is, when should an organization actually use blockchain? So particularly when there's a need for a database or some kind of shared repository of information with multiple trustless and potentially corrupt writers, and also where there's a need for some kind of verification or transaction management. So in healthcare, the obvious applications of blockchain are, of course, in patient record storage and in pharmacy fulfillment, where there's a need for secure storage and access of medical data between patient and medical provider, as well as verification for the dispensing of medicines. Finance has a lot of interesting use cases. Settlements and contracts of all kinds can be optimized with blockchain. A particularly interesting example is in oil futures, where essentially the deal terms can be automatically confirmed and recorded on the blockchain and available to the pipeline that's actually shipping the gas. And as the gas flows throughout the month, physical settlement on the contract will occur daily, and payment can be initiated immediately right away. So all of this activity will be recorded on the blockchain, and this data is available to the seller, the buyer, the bank, as well as the pipeline. For digital identity authentication, employee management, and IP management, these are all possible applications of blockchains because of their need for a single verifiable source of truth. And DAOs are, of course, interesting applications of autonomous smart contracts that lock trade deals into the blockchain. So some notable companies that are offering meaningful solutions in the blockchain space currently are Trust Token, which allows for asset-backed token securities. This virtually opens the door for any kind of fractional ownership in any asset. Chronicle uses blockchain and IoT to monitor and verify shipments in various supply chains. Lemonade uses AI to formulate competitive insurance rates, and then uses blockchain to lock users into those payment agreements, and that speeds up the time of both the claims as well as the payouts. And Patientory provides an accessible and secure application for storing and accessing medical data between patient and healthcare provider. So what's the future of blockchain technology? The future of blockchain tech will focus on decentralizing and optimizing virtually any and all services requiring trust authentication or verifiability. Many aspects of finance are going to be completely decentralized or autonomized in some way with the blockchain. And there's also going to be lots of new, completely novel applications for blockchain technology that none of us would have really been able to foresee at this time. So before we conclude, I'd like to make a quick announcement. Dr. Akcora, myself, and our team have actually started a company focusing on addressing many of the needs we've outlined in compliance and data analysis. We are currently building out demos of a compliance solution for AML and ransomware detection, anti-money laundering and ransomware detection, as well as various algorithmic trading strategies and portfolio management strategies that leverage our research techniques. Our team has had over 15 peer-reviewed blockchain publications in computer science, finance, and statistics venues. Our team is listed right here. If any of you guys in the audience potentially are in banking or finance, or if you have contacts in banking and finance and you think that these people might be interested in seeing our demo or learning more about our products, please give them our contact information, and we'd love to develop that relationship with them and potentially showcase what we have and demo our product to them. For any other questions regarding our company or solutions, you can contact us as follows. Thank you guys so much. Thanks to Rhonda Bush and Beth McLean again for giving us this opportunity. Thank you so much.
And thank you for your presentation. If you want to leave that slide up there so everybody has your email addresses. And what I'm going to do is start putting out there some of the different questions that we have had that have come up so far. So one of the first questions is more about blockchain in general and looking at one of the applications. So in the supply chain setup, who do you believe will have to orchestrate the blockchain? And also, how do you ensure it's not a zero-sum game?
So the way I see it is the person who would be facilitating the use of the blockchain would be some kind of third-party software technology company that's offering their product to logistics companies that have supply chain needs, and they would likely pay for it. It would likely be some kind of software as a service type platform. And with regards to how do you ensure it not being a zero-sum game, I'm not totally sure if I'm understanding what you mean in the context of that. Maybe if you can provide a little more insight on what exactly a zero-sum game means, I can potentially address the second part of that question.
Okay, so I'll wait to see if that the clarification comes in. So another question that came up is so how is blockchain relevant as a use case to companies that are doing big data?
Yes, so in terms of writing data and querying data, blockchains cannot win over traditional database schemes. So whenever we deal with big data, usually we open blockchain, take its data into a new database, for example, or an analytics platform, and then try to execute our algorithms. So in terms of big data, blockchains cannot really be helpful. Blockchains need to be agile because most of the blocks are just dead weight sitting in your computer. So big data and blockchains can only work if the blockchain provides smart contracts to do something with the data. But the data must be stored somewhere else, especially if you don't care about multiple versions. And for the previous question, before I want to say something. Sudhanva mentioned the third party that will provide these as a service. This is actually IBM already doing it. So if you search internet for IBM Hyperledger, IBM has been very active in developing these and providing it as a service.
All right, thank you. So another question that we have had, in the context of the massive amounts of disinformation surrounding COVID-19, can you speak to any use cases for blockchain to be used in reporting, either private news agencies or governmental?
I mean, in terms of trustworthy data, blockchains can be used. We don't see that very much, but blockchains can be used for accountability. So you could write your data and your opinion and rules to the blockchain, and you cannot change them in the future. These days, COVID has ushered an age of contact tracing applications, for example. And right now, I'm actually developing such an application in Canada with a company. We are using the decentralized storage and decentralized search options of blockchains. So we are taking the underlying technology of blockchain in terms of peer-to-peer network, and we are using it for searching in the social graph. So these aspects can be used. Sudhanva, do you have an opinion about this?
Excuse me, what was that?
Do you have some use cases about the governments and companies using blockchains for trust issues, misinformation?
I think the explanation you gave was pretty good. Off the top of my head, I can't think of any others where any other instances where blockchain is almost used to like verify current event type information almost, because I'm assuming that that's what the person who asked the question is implying, that it's some kind of like current event or like social data. and how blockchain and its verifiability can be used to combat the spread of misinformation. And in that particular context, I can't really think of another example off the top of my head.
Okay. So we have a slightly different question from somebody who does not have any computer science background. Do you have any materials or suggestions for resources that would help somebody learn this information and understand blockchain better in order to integrate its function into future businesses?
I think there's various really good resources on the internet just for learning about blockchain and Bitcoin. You can start off by reading the actual white paper, which might be a little too much to approach when you're first like getting introduced to all of this information. But I think if you spend enough time online, just watching different videos or watching different courses, people will walk you through the very basic stages of what a blockchain is and how it's developed, and as well as Bitcoin and other cryptocurrencies. So I think it is very much approachable to a person who doesn't really have any sort of technical background in this.
I have something to say about this. Actually, recently we wrote such a piece for Harvard Data Science Review. It is under peer review yet, but if this person who asked the question can give you an email address from them, we could maybe give a copy to him. That would be possible.
Okay, so that's another option. So for anybody who's interested, if you want to send an email, then you can also get some additional information that way. So we have another question. If I'm creating a blockchain consortium, I would want my partners also to be in the consortium. So how would the partners who will be in that, how will their interests be protected? As a consortium lead, I may have a hidden agenda of saving money, but partners may incur costs. So I guess the underlying question is, how do you, if you're using a blockchain for the consortium, how do you protect individual interests?
I can answer that question. So smart contracts are the perfect tools for this, right? So smart contracts are exactly created to write these rules of the company. So you can create complex smart contracts that will protect everyone.
All right, so we've got 2 more questions so far. What are the key challenges in adapting blockchain, any non-crypto version, in organizations that have a heavy resilience on product supply chain, and how can we overcome those challenges?
Well, from the standpoint of challenges, I think for most developed corporate environments and organizations, the main constraint is really just going to be the cost of the software. I don't think that implementing it or anything like that is going to be a problem whatsoever. I think the main issue in implementing a technology like this in a corporate setting is just making sure that everyone else is on board with the implementation of this technology, sort of from like a managerial standpoint. So it's really just being able to communicate the value of what this blockchain product will bring to your organization, and being able to communicate to upper management how this will significantly impact your organization's bottom line. So for example, if you are a shipping and logistics company and you talk to your upper management and say that, hey, this new blockchain system that can help us verify shipments as they're coming in real time can help us save, whatever, like 12 to 15% worth of wasted product a year. Metrics like that will help efficiently communicate the value of blockchain for your specific organization and your use case.
Okay, thank you. So we're down to our last question. Can you just go over again some of the standards that are in place and the governance, or what the governance looks like within the blockchain specifically for cryptocurrencies?
Dr. Akcora, would you like to take that one?
Yes, let me talk about technical issues first. So most of the legal issues about blockchains are about know your customer rules, because malicious people, especially ransomware people, are using blockchains, using cryptocurrencies to receive ransom payments. So the governments are very serious about it. Other than know your customer rules, we have other crypto asset price manipulation avoidance rules. These are still in development. So we cannot talk about a unified set of rules. But the body of work is accumulating. For example, recently Oxford had published a book about crypto asset regulation. I would recommend searching for it. At this point, the token, stablecoin, all these, and especially ICOs, are just managed by ad hoc rules, let's say. New York created the first rule to regulate the cryptocurrencies in 2015. After that, we were expecting a strong push. It didn't come, mainly because blockchain people are very averse to rules and regulations. So they don't want to see anything. They are really pushing against government efforts.
All right, well, thank you. So I want to thank everybody for joining us today. I believe that we've had a very wonderful discussion about blockchain, and hopefully everybody understands a little bit more about both blockchain and cryptocurrency. So at this time, what I want to do is say thank you to both Dr. Akcora and to Sudhanva Purushotham for joining us and to presenting the topic and to answering your questions. And please feel free to reach out to either of them as they shared their email addresses if you have additional questions about either their research or what their future looks like with respect to cryptocurrency. So thank you for joining us and have a great afternoon.